Hey everyone, I'm Dheeraj from CSC. Today I'm going to explain about heap and heap sort. There are mainly two types of binary trees. One which is full binary tree, which is almost complete binary tree. A binary tree which each node is either leaf or has a degree of exactly 2. Like this, like 2, there is only 14 and 8, which is no, for nodes for 14 and 8. And another which is complete binary tree, a binary tree in which all leaves are on the same level and the internal nodes have degree 2. Like 4 has 1 and 3 and 1 has 2 and 10, which is complete a binary tree. Definitions of binary tree are height of a node, the number of edges of the longest simple path from the node to down to the leaf, which is, for example, height of 2 is 1, which is the node is only 1 here, and level of node is the level of a path from root to the node. The height of the root is 1, 1, 2, 3, so the root is 3, and the height of a tree is the height from the values from the root 1, 2, 3. Coming to heap data structure, a heap is a nearly complete binary tree with following two properties. Structural property, all leaves are full except possibly last one which is filled with left to right. Basically, it's a almost complete binary tree. Order of heap property is for any node x, parent of x should be x. That is, parent of x should be greater than the child of parent. The heap can be sorted in an array. Likewise, the root of a tree is AF1. Always the root is AF1, that is 16. The left child is AF2 of I. 2 of I is 1. And the 14, the left child is 14. And the right child is 2 of I plus 1. 2 of I is 2, which is 10, the right child. And the parent of I is I by 2. 2 by 2 is 1, which is the parent of AFI. Always the heap size is lesser than or equal to length of A. The elements in a subarray is A of n by 2 plus 1 into n R leaves. There are two types of heaps. Maximum heap, largest element at root, have the maximum heap property. For all nodes I excluding the root, A of parent of I is greater than or equal to A of I. And minimum heap, smallest element at root, have the minimum heap property for all node I, excluding the root. A of parent of I is lesser than or equal to A of I. Adding or deleting nodes. Adding nodes are always inserted at the bottom level, left to right. The nodes are removed from the bottom level, right to left. For maintaining the heap property, suppose the node is smaller than the child, left and right substrees of I are maximum heaps. To eliminate the violation, exchange with larger child, move down to the tree, continue until the node is smaller than the child. For example, here the 14 is greater than 4, hence heapify the 4 and 14. While heapifying, 4 comes down and the 14 goes up. Again come to the child node 4 which is 4 and 8. Here the 4 is smaller than 8. Again the heapify to get the heap value sorted, which is the greater number should be maximum EPFI running time is it traces a path from root to the leaf, longest path length h. If each level makes exactly two comparisons, total number of comparison is 2h. Running time is O of h or O log n. Running time of maximum EPFI is O of log n. Building a heap is that the heap is given in an array of A of 1 is to n, which is converted into maximum if n is equal to length of A. The elements in a subarray A of n by 2 plus 1 are leaves. Apply maximum EPFI on elements between 1 and n by 2. Which the given example is this 4, 1, 3, 2, 16, 9, 10, 14, and 18. Here the array of A is given in 4, 1, 3, 2, 16. Like this, the heap is constructed like 4, 1, 3. But to get the heap value, 1 is lesser than 16, which should be 16 should be come here. And 14 is greater than 2, and 3 is lesser than 4. Again, we should simplify it, and when 14 comes up and 3 goes down and 10 comes up, and doing this, we'll get the maximum value, which is 16, which is maximum value. Then the heap is constructed. Heap sort is a method where you can sort an array using heap representation. The idea is that you can build a maximum heap from an array, swapping the root, the maximum element with the last element in an array, discard the last node by decreasing the heap size, call the maximum heapify on the next root, repeat the process until the root is fully finished until you get the heap order which is in decreasing order. For example, A is the array is given as 7, 4, 3, 1, 2. Here, binary tree is sorted 7, 4, 3, 1, 2, and the heap sort begins when 2 is given in the place of 2, where 7 is given as I, and check if it's in maximum heap or not. Yes, it is in maximum heap, and then convert and place the 1 in the place of 4 with and check the value if it is in maximum heap, which is in maximum heap, and place the 1 on 3 where 3 comes out and the value is given as 2, 1, which is in when epified. The 2 comes out given as given value will come as 1, 2, 3, 4, 7 in which is sorted in a heap sort. The type complexity of heap sort given as when for loop runs O of n occurs, and when the heapify occurs, O of log of n occurs, which is combined well n of n minus 1 times. Running both gives the value as O of n log n. Heap extract maximum value is the goal is to extract the largest element on the heap, returns the maximum value, and also remove the element on the heap. Idea is to exchange the root element with the last, decrease the size of the heap by one element, call maximum heapify on the new root on the heap of the size n minus 1. Heap A is 7, which is the root of the element, which is the largest element if it is taken out as the largest element. For example, here the heap is given. 1 is given to the place of 16, where the maximum is taken as 16 in the heap. Again, it is heapified to give the maximum value in the root, where here it is the 40. The 14 is taken out as the maximum element in the heap. Likewise, it continues heapifying it. Here, the maximum heap insert. The goal is to insert a new element into a maximum heap. The idea is to expand the maximum heap with a new element whose element key is infinity. First, the infinity key is given. Call heap increase key to set the key to the new node to its current value and maintain the heap value properly. And the given value is given, and uh, the heap is converted into maximum heap in the given value. For example of inserting a value in the heap, for inserting a value of 15, first we will start with inserting a value of infinity to the lowest point of the heap where it is given as infinity. Then call the increase key as A of 11 is equal to 15. 15 is given. Here we can see that 17 is lesser than 15. It does not match heap property, so it is EP5 like 7 is coming down and 15 is going up. And here also 14 and 15, 14 is lesser than 15. And again 14 and 15 are EP5. 15 it comes up and 14 goes down and the EP is satisfied 16, 15, 14, 8 and 2, 1.